maximum angle of incidence is called acceptance angle. So this is equals to theta equals to sine inverse under root n1 square minus n2 square upon n0. Here n1 is the core refractive index, n2 is cladding refractive index, and n0 is outer zone refractive index. Outer zone is from where the light is incident on this core. So we are launching our derivation. Here observe, here you record some observation. Here you see the light ray incident at the theta I, and as this medium and this medium is different, so it will get refracted. Here it will get refracted at the angle of theta r. So here we apply Snell's law. What is Snell's law? Here we can write as sine theta I upon sine theta r equals to n naught. N naught is outer region diffractive index and n1 is inner. n1 upon n naught. So this is our equation from Snell's law. Here we can it is right as that, and now we are having this ray which is going to the surface of the core and refracted back to its core region. This ray is successively passes through all the time, and it will carry on till the optical fiber is not end. So we know that the concept of TIR. Here N1 is quite greater than N2. That's why the factor of TIR it's happening here. Now we are considering triangle ABC, A, B and C. Can you see it? In this triangle we can use triangle's property, that is theta r plus theta equals to 90 degree. We are considering that this is, wait a minute, this is 90 degree, and what is the sum of all angles in a triangle? It is 180 degree. So phi plus theta r plus 90 degree equals to 180 degree, that is theta plus theta r plus phi equals to 90 degree. Theta r equals to 90 minus phi, and now we are taking sine both sides. Sine theta r equals to sine 90 minus phi. This sine and this sine is we are considering from here, so don't get confused why we are using it. Now we know that sine 90 minus theta is equals to cos theta. Simply we can write it as cos phi. This cos phi we are using this cos phi in our equation first, and this is our equation first, that is Snell's law equation. Theta r value is replaced by cos phi, and this is will be considered equation 2. Now this equation 2 for acceptance angles, that is the maximum angle of incidence, is now be considered as theta I equals to theta I max. When this is happen, there is also one phenomena happen, that is phi will be changed into critical angle. This thing you have to take in your mind, keep in your mind, that phi will be changed into phi c, that is critical angle. Now this equation will be written as sine theta I max equals to n1 upon n0 cos phi c. taken it as equation 3. Here we can see that from this side the light ray will go in this region. So if it will not go, then it will be absorbed here. So the angle that it will form for the critical angle of incidence is 90 degree. Here we have to understand that here the refraction is occurred but absorption also, because critical we are incident the ray at a critical point and it will get absorbed, and after it critical angle it will get PIR, it will get reflected back if we increase the critical angle. So at critical angle here we get N1 sin phi. N1 sin phi is N1 core refractive index into cladding refractive index. Sin nt is the angle at which the ray refracted. Okay, now sin phi c is equals to N2 upon N1 as sin 90 is equals to 1. Now we are using sin square theta plus cos square theta equals to 1. So cos phi c is will be written as under root 1 minus sin square phi c, and now sin square phi c is this value. We will square this value and written is at that. Now we will get the value of cos phi. This cos phi will be written as this. This will go there and take in LCM, and n1 square will go out of the square root, so it will be written as this. Now putting value of the above equation in equation 3, here where we can put the value, we have cos phi, so this cos phi is replaced by this value. When we replace this value, n1 and n1 will be cut off, and now we will get sin theta max equals to under root n minus n square minus n2 square upon n naught. And for the maximum incident angle, we will switch our sign to this side, that is we will take inverse sin inverse both sides. This sin inverse will be written as that, and this I theta I max can be written as theta naught, that is acceptance angles. This is will be also right, but we are initially considered it theta naught is the acceptance angle, that's why we are at the end considering theta I max. So here we get our answer. Thank you.